So here's a summary of what we've learned over the last 4 videos. When we multiply together a normal to a normal, getting a normal result, the exponent's given by the unbiased exponent ex plus the unbiased exponent ey, and then we add on the 127 as a bias, and finally we either add on the value of 0 or 1 depending on the 48th bit of the multiplication. And the mantissa is either shifted left, that's the decimal point of the mantissa is shifted left by a value of 0 or a value of 1 depending on the leading bit of the multiplication, that is the 48th bit. Then we looked at normal times the subnormal, giving the normal result. And what we did was we took the value of our unbiased exponent ex or ey, whichever one was the subnormal number, and we made that value minus 126 minus the pre-leading 0 count. So this is the leading 0 count of the subnormal number, also including the 24th bit, which is the hidden bit, which is a 0 for a subnormal number. So as long as we kept this, or we made this true, then we could create the exponent by adding up the value of the unbiased exponent ex plus the unbiased exponent ey. So again, one of these has been changed as per above. We added on the bias 127, and then we add on the value of either 0 or 1 depending on the 48th bit, and the mantissa decimal point is going to shift left by a value of 0 or 1 depending on the 48th bit. We then looked at a normal times a subnormal, giving a subnormal result, and we've seen again that we generated the unbiased exponent ex or ey depending on which one is subnormal, and it was created as minus 126 minus the pre-leading 0 count. The exponent value is forced to all zeros because the output is subnormal, and the mantissa decimal point is again shifted left, but it's shifted left by this value ex plus ey plus the bias, which is 127 plus 1, and we have to include the leading zeros whenever we perform this shift. Finally, we looked at normal times the normal, given a subnormal, and the exponent values again we set were all 0, and the mantissa again is a left shift by this ex plus ey plus the bias, which is 127 plus the value of 1, and again we have to add in the leading zeros. So these 4 little algorithms are at the heart of our multiplier. So let's go ahead and we'll update our multiplier black box, and we'll see how we can build an entire multiplier.